Welcome or welcome back at Cisco. In this lesson we will talk about angles. And you see here the definition of an angle. An angle is formed by two rays. You see here in the picture ray AB and ray AC. The common endpoint, this guy here, you notice I call them ray AB and ray AC. It's called a vertex. And we can use different way to call an angle. We call this angle you see here angle A, it's okay. Also we can use three letters and you notice we call it BAC. Also CAB, it's okay, CAB, and you see how I go from one point to another point to the next point. I would like you to notice that the vertex is in the middle and the last choice is to use a number, like in this case angle 1. So there are multiple ways to call on angles and you'll see in this lesson I will use all these ways probably. Angles can be measured using what is called a protractor, a tool like this, and you'll see in this lesson I will show you how to measure using a protractor in case you need it. So now, if you remember, I said there are multiple ways to call an angle. Most of the time you're going to use three letters. Why? Because sometimes you can have an angle, you can have angles that share the same vertex. Like in this case, you notice angle 1, 2, and 3, they share the same vertex F. So if you call this angle F, it's already a problem because you don't know which one it is. However, if you call angle 1, you call angle AFB, that's okay. Look at here, AFB, and again you notice how I move, or BFA, BFA. Angle 2, you can call it what? BFC or CFB, and angle 3, very similar, we can call it CFD or DFC. So very important, most of the time you're going to need to call an angle using three letters. Remember, the vertex is in the middle. Let's take a look how we classify angles, and you notice here we have four types of angles in this lesson. We have acute angles like this one. This angle here is less than 90. A right angle, it's an angle that is exactly 90 degrees, and you will see most of the time a box like this, unless it tells you that the angle measures 90 degrees. We have what we call an obtuse angle, like this one. D is between 90 and 180. And the last angle, it's what we call a straight angle. This angle is 180 degrees. And it forms like a line. Well, there are angles that are more than 180, but I'm not going to discuss in this lesson. So let's take a look on the first example. We have to name each angle in different ways, and we need to use a protractor to find the measure and classify as an acute, right, or obtuse, or straight angle. So how can I call this angle? I can call it very simple, angle 1. I can call it angle A, that's okay. I can call it one more way, NAM, and of course I have a fourth way, which is MAN. And this angle, if you take a look, I don't have the protractor here, you'll see it in the next problem, is an acute angle, less than 90. Let's take a look to the second angle, this one, angle 2, obviously. What will be another way to call it? Will be DAB, angle DBC, angle CBD, and simply you can call it angle B in this case. This one is what we call an obtuse angle, more than 90, less than 180. In this my second example, you see what I said, the protractor. So we're gonna use this protractor you see here to measure angles, and we're gonna start with this one, first one, angle RML. I'm gonna do the same thing. I'm gonna go and mark the points R, M, L. That tells me we have this angle. This angle is an acute angle. You notice it's less than 90. And for that reason, I'm going to use these blue scales and I'm going to look where this side ML cross this protractor, and I can see this 50 here. That angle is 50 degrees, and like I said, it's an acute angle. Let's take a look to part B. How much is this angle? KMR. KMR. This is this guy here, and you notice already I made a box. Why? If you take a look on the blue scale, we can see 90 here. Can I look on the black scale? Yes, but I will say use the blue one since we have this side of the angle MR, this ray MR, and this ray MK. So this is 90 degree. And if you remember, how do we call an angle that is 90 degree? We call it a right angle. Let's take a look to the next part C. This one, RMT. Again, RMT, this angle. So let me erase the other markings. I have here these two, and now we can see better. This is the angle, which is a obtuse angle, and again I'm going to use the blue scale, and I'm going to notice is right here 130. That is 130 degree, and this is an obtuse. And we have here angle part D. We have angle NMR. So let's take a look. NMR. Wow, this is what we call an angle that measure 180 degree. I'm going to put it here. If you take a look, is this angle NMR. And if you take a look, we're going to use the black scale now to follow the direction, and that is 180 degree, like I said, and this is a straight angle. Okay, let's take a look to part E. Angle NMT. NMT. Okay, let me erase again these arcs. And again, NMT is going to be this angle. NMT, which is an acute angle. And what scale do you think I'm going to use now? I'm going to use the black one, and I will take a look, and that is 50. Let me erase the other to be sure we are not confused. Okay, so that angle is 50 degrees and is like RML. This we call them congruent angle, by the way, because they have the same measure. You will hear me saying that a little bit later. And let's take a look to part F. TMK. Okay, so there you go. TMK. How much is that angle? So this one is a little bit different than the others, right? We need to be careful. Let's first mark the angle. TMK is this angle. So how much is going to be this angle? First of all, we can notice this is an acute angle. And how are we going to see how much it is? You have two choices. We can take a look on this blue scale and we can see, hey, it's from 130 to 90. On the black scale, we have from 90 to 50. Either way, we can see that means is 40 degrees. That's one way to measure using the protractor this way. Let's take a look now to the next one, but let me erase this marking, and we have the angle LMK. LMK. Okay, this angle. right? How much is going to be this angle? We notice 90 here, 50 here. Okay, so it's going to be what? 40 degrees. Okay, if you take a look on the black scale, 90 here, 130 here, you should see that 40 degree also. Acute angle. And again, you notice these two angles have the same measure, TMK and LMK. They are congruent angle. You'll hear me saying that later. Now let's take a look to the last one in this problem. We have angle LMT. LMT. Okay, this is this angle. And we can see 130 here, 50 here. That will be 80 degrees. And that will be still an acute angle. Let's go to the next part of the lesson. We have something that is called angle addition postulate, very similar with the segment addition postulate, which I presented in a different lesson, which means what? If this angle is 50, for example, and this angle is 40, how much will be this angle? That will be 40 plus 50. And of course, my picture is not accurate, so let me change a little bit the number just to make a little bit more sense. So let's say that angle is 70 and this angle is 50. That angle will be 120. That is what we call the angle addition postulate, which you see it here and also here. And it says if a point C is an interior for angles AOB, you see that here. Then we have this property. And let's use this angle addition postulate for this problem. You notice here we have in part A, we need to find the measure of angle BAD, this guy. Okay, so how much is that angle? So first of all, let me show you the angle addition postulate, the geometry of this problem. The measure of angles BAD, the one we need to find out, is equal to the measure of angles BAC plus the measure of angle CAD. So probably most of you are just going to do what? 63 plus 52, which is fine, but just have in your mind this statement is an important statement in geometry on this lesson. So 63 plus 52, that will be 115 degree. That is how much this angle here is. Let's go and take a look to part B. Part B, we have now expression here. X minus 8 is the measure of angle MFT, and TFL, the measure of angle TFL, is 3x plus 22. We need to find the measure of angle LFT, this one here, and we know LFM, the measure of angle LFM, the big angle, let me call it like that, is 114. So I'm going to write a very similar statement, measure of angle LFM. Let's do this way to be consistent with the problem, but it's okay if you write the other way. MFL equals what? The measure of angle LFT plus the measure of angle TFM. So now we're going to replace this geometry with some algebraic expression, and you notice angle, the measure of angle LFM. LFM, it's 114, that's my first thing. And then the measure of angle LFT, this is 3x plus 22. And the measure of angle TFM, it's x minus 8. So now this is algebra. We're going to have 114 equals what? 3x plus x, that is 4x. These two, we combine them, they are alike. And then we have 22 minus 8. That will be plus 14. So my next thing will be to subtract 14 to get rid of these 14. Don't forget to do the same thing on the other side, in this case the left side. And we have here 100 equals 4x. And what will be the last step to find x? Divide by 4. So we have x equals 25, which is the first step in this problem. Now, don't forget, we need to find the measure of angle LFT. Well, how are we going to do that? We just need to plug it in, replace x in the expression that represents this angle. LFT, 3x plus 22, 3 times 25 plus 22, that will be 75 plus 22, and that will be 97 degree. This is the measure of angle LFT. Okay, I mentioned a couple minutes ago about congruent angles. They have the same measure. If you remember, I said that. And you can see these two angles are congruent. Why? They have the same marking. Angle A, this is the sine congruent to angle B, or you can say the measure of angle A equals the measure of angle B. And very similar in the other picture, we notice these two angles are congruent. The only difference, I have to use 3 letters. I'm going to say angle DMK congruent with angle KML. And you can write this statement very similar to the other one using the measure of the angles. Let's take a look to this example. Figure can contain multiple angles like in this problem, and we need to extract information from the picture. Like in this case, let's take a look to part A, which says angle ABE congruent to what? Let's take a look. ABE is right here. It has 2 arcs as a marking. So which one has 2 arcs? We notice is this guy here, nothing else. So that's the angle, and I'm gonna write it here, angle, don't say D, it's not good enough, use 3 letters, and one way will be GDC. Let's take a look to part B. We're looking for angle FCB. Let me change the color. FCB is this angle with 3 marking. Hey, this is the angle that has also 3 marks. So that will be what? Angle DCM. DCM is the angle that is the same with the angle FCB based on the picture and marking. Now let's take a look to the last problem here, last part. If the measure of angle FCB, oh, again, this angle here, it's 47, how much is going to be MCD? I'm looking to MCD, which is this angle, the congruent angle of this. We see that here, but the other way. If they are congruent, they have the same measure, so it's going to be 47 degree. And if you notice, just as a fact, in this picture we have another pair of angles that are the same, this one and this one. You can try to write a statement very similar with these 3 statements here, if you want. Now let's move to the next part, and in the next part we can see that the angle addition postulate can be applied in problem with multiple angles, like in this case. Do you notice? We have this angle here and AM 30, this angle here, angle TAN 45, and this angle here is 35 R80. So how much is going to be the, for example, angle RAM? You can add all these 3 things. I think I have it here. That will be 110 degrees. So keep in your mind, you can do that. And you see here the geometry and then how I replace each one and get the answer. Oh, let's see how we use what I just mentioned in a problem like this. Use the figure below and find the measure of each angle. And we know angle RTS, this one here. This one here is x plus 24. So probably sometime you may want to mark the expression, if it's possible, on your picture. STP, this angle here, which I'm going to mark it a little bit different. It's 2x plus 7. And the angle PTV, this one, let's mark like this, is 3x minus 35. Okay, so these are the expression given for each angle, and we have one more information. The measure of angle RTV. Woo, this big angle is 122. So you may look here, 122 degrees, too much on the picture, but sometimes that helps. Okay, we need to find the measure of each angle. So what do you think I'm going to write here? I'm going to write exactly what we've seen before. Measure of angle RTV, this big angle, the biggest angle, is equal to what? The measure of angle RTS plus the measure of angle STP plus the measure of angle PTV. Okay, so exactly what we've seen in the previous slide. And now I'm going to replace them with the value or the expression given. RTV, the measure of angle RTV is 122 degrees. The measure of angles RTS, x plus 24. The measure of angle STP, 2x plus 7. And the last one, the measure of angles PTV, 3x minus 35. Okay, so that was the geometry. Now let's take a look to how we handle this algebra. 122 on the left side stayed like that, at least in this moment. Let's combine the x's, x, 2x and 3x, that will be 6x, right? Then we have positive 24 plus 7, that is positive 31, minus 35, that will be minus 4. Okay, and now with a two-step equation, I'm going to add 4 to get rid of this minus 4, add 4 here for the same reason, to keep the balance. And we have here 126 equals 6x. Last step to solve the equation is to divide by 6 to cancel this 6. We're going to do the same thing on the other side, and we have an x of 21. Okay, but again, we need to look. The problem says find the measure of each angle. So let's start with the angle RTS. The measure of angle RTS is what? X plus 24. So it's going to be 21 plus 24, and that will be 45 degrees. Okay, let's move to the next angle. The angle STP. The measure of angle STP, if you take a look, it's 2x plus 27, so that will be 2. Let me get closer to the statement. 2 times 21 plus 7. So 2 times 21, it's 42, plus 7, 49 degrees. Okay, we have one more angle to find out. The measure of angles PTV. And that will be 3x, so 3 times 21 minus 35. So that will be 63 minus 35. That will be what? You can grab a calculator and be sure you do the right job. 28 degrees. So the measure of angles PTV, it's 28 degrees. Of course, the last step you can do in this problem to check if you are correct or wrong is to add these three values and see if you get 122. Okay, as a checking point. Let's take a look to the next problem, and in this one we have the measure of, use the figure below, find the value of x and find the measure of angle AVB, this angle. We know that angle BVC, this angle here, I'm going to mark it different because I don't know if they are the same. This one is 2x plus 7. And angle CVB, this angle, it's x plus 11. X plus 11. So now, if we take a look, AVB, by the way, is 3x minus 23. What do you notice in this picture? And this is very important. Okay, so this problem looks similar to the other one, however, is different, right? I mean, a little bit different. What you should notice is that these two angles, this one and this one, are congruent because they have the same arc. So you can write something like this if you are a geometry student, which I know you are. The angle AVB is congruent with angle CVD. So you notice we can extract, we can get information from the picture, and that's the information we get it from here. Of course, you can go and write this statement if you really want to be a geometry student, which says the measure of angle AVB is equal with the measure of angle CVD. And of course, you can write this statement, 3x minus 23 equals x plus 11. This statement will allow us to find x, because now I will subtract x, that's my way, and I will do that to get rid of this x. Don't forget to do that in the other side, and we have here 2x minus 23 equals 11. I'm gonna add 23, and that will give us 2x equals 34, divide by 2, and we have the x, which was the first step in this problem. We need to find x, so let's circle the answer. Now we have to find the measure of each angle, which I'm going to do it here on this right side. So let's start with the first one, the measure of angles AVB. If you take a look, that is 3x minus 23. So that will be 3 times 17 minus 23. 3 times 17, 30, 51 minus 23, and that will be 8 and 28 degrees. Okay, good. Right away I can do something else. I can go and do the last one, the angle CVD. And I'm not going to do any math. I'm going to just say 28. Why? Why? Because these two angles are congruent. Of course, it's not super complicated. Plug 17 here and you'll see it. You get 28. That is a checking point, by the way. And let's find out the last one. Angle, the measure of angle BVC. Now it is, so you notice here, 2x plus 7. So 2 times 17 plus 7. 2 times 17 is 34 plus 7. That will be 41 degrees. That's the measure of angle BVC. Okay. My next part in this lesson will be about angle bisector. And you notice here I said an angle bisector is a line. It can be a ray, it can be a segment that divides the angle into congruent parts. Like in this case, we have this ray, Ln, breaks the angle MLT into congruent parts. You can see my statement here. These two angles are congruent. The measure are the same. Moreover, the measure of each angle is half of the big angle. That's one way to say it. And I will say another way. Twice each angle, MLN, the measure of angle MLN, or twice the measure of the angle TLN will be the big angle, the measure of angle MLT. Sometimes I prefer MLT, not S. Sometimes I prefer this statement than this one, which is very good, but it has fraction. Okay, so let's take a look to an example like this one. We have this figure below, and we need to find the measure of angle MLN, this angle, which you notice is the same of this one, the picture tells us. So in other words, Ln is an angle bisector if the measure of angle MLN is 3x plus 16 and the measure of angle TLN, this one, is 5x minus 12. So right away we can write geometry. I'm gonna be a good geometry teacher, and I'm gonna write the angle MLN congruent with angle NLT. Obviously we can write the next statement, the measure of angles MLN equals with the measure of angles NLT, and obviously the last statement, I mean it's not going to be the last statement, the next statement is going to be this one, 3x plus 16 equals 5x minus 12, right? And now we're going to solve this equation. I'm going to be consistent. I'm going to use the same way. I'm going to eliminate x's first. So that's the reason I'm going to subtract 3x to get rid of these 3x. I have to do the same thing on the other side, and I have here what left? 16 equals 5x minus 3x, 2x plus 12. My next step, minus 12 in fact, let's be sure. Minus 12 here. So I'm gonna add 12 here to get rid of these minus 12. Add 12 on the other side, and we have what here? 28 equals 2x, divide by 2, and we finish the x. The x will be nothing else than 14. Okay, and now we need to find the measure of angle MLN, which I'm going to do it here on the right side, and that will be 3x plus 16. 3 times 14 plus 16. 3 times 14, that will be 42 plus 16, that will be 58 degrees. The measure of angle MLN. the next thing will be to find the measure of angles MLT, the big angle. So now be careful. A measure of angle MLT, an easy way to do it is just to 2 times the measure of angle MLN. Right? The big angle is twice each of these small angles, so that will be 2 times 58, and that will be 116 degrees. The measure of angles MLT. Okay, again, very important to read the problem carefully. And let's move to my last problem in this lesson. Use the figure below where RT bisect angles PRS. So that being given, I will say the first thing you want to do is mark like this, these two angles. They are congruent. Why? Because RT bisect angles PRS. That's the meaning. Now we need to find the measure of angles TRS and PRS if the measure of angles TRS is 2x plus 6 and the measure of angles PRS, oops, this is this big angle, it's 5x minus 12. So what you want to do here is to write this statement here. Twice the measure of angles TRS is equals to the measure of angle PRS. Right? And one more time, this ray bisect angles PRS, so that means each of these angles, it's half of the big angles, or like I said, I prefer this statement, it makes the job easier. So we have twice the measure, let me replace the measure of angles TRS, 2x plus 6 equals the measure of angles PRS, 5x minus 12. So now we have an equation. I think the best way is to do distributive property, and that will be 4x plus 12 on the left side, the right side stay as it is. And now I'm going to be consistent. If you remember, I like to get rid of the x's, so that's the reason I'm subtract 4x here. I'm going to subtract 4x here, and I get here what? 12 equals 5x minus 4x is x minus 12. Last step to find x is at 12, right? Because you want to get rid of these 12, so x will be nothing else than 24. Okay, but what do we need to find? Find the measure of angles TRS. The measure of angles TRS is this expression, 2x plus 6, so we have 2 times 24 plus 6, and that will be 48 plus 6, and that will be 54 degrees. The measure of angles TRS is 54. What is the other angles we need to find out? PRS. So how much is going to be the measure of angles PRS? Okay, you have two choices. You can say plug that 24 in this expression, 5 times 24 minus 12, you can do that, or simply double the 54. I think that's the easy way, and that'll be 108 degrees. That's the measure of angles PRS. Of course, you may want to check if that's correct by looking here. 5 times 24, that will be 5 times 4, 20, 0 and 2, 120. minus 12. Yep, that is 108. So we check it very fast. And that's it for this lesson. If you enjoyed this lesson, don't forget to click the like button. Come back on C-Square for more help. Thank you.